Okay, so
all that.
Since you have seen a great prototyping tool in audio space, we'll see one in visual space, slightly more boring one. So this is work done by me and 3 other undergraduate researchers in Chroma Lab, and Chroma Lab is directed by Professor Walter and so creating sketch prototype is an essential step in user interface design, and it helps designers to quickly explore different design ideas and use it to communicate with other colleagues. Because once you see it, it's easy to get a sense on how the final UI is going to look like. However, it's not clear to know what is going to happen if you, when you interact with it. So let's say, for example, for example, what happens when the user clicks it or swipes the menu item and it's not well represented in the sketch, mainly because it's a static sketch. So it was found that designing your UI behavior is particularly challenging, according to a previous study. Typically, what designers do is to describe the behavior in text on top of the static sketch. And however, if you think of the actual behavior in final UIs, like the final products you see in the bottom, it would have been difficult to get the same feeling that you get when you see it from the textual description. For example, like the one in the middle is when Steve Jobs demonstrated swipe to unlock 10 years ago. And people were applauding and screaming, and then you don't get the same excitement when you read swipe to unlock. So, and then it gets worse for other highly interactive apps like games. So, and today's UI prototype software provides some solution to this. Like you see here, typically a user can choose from the library of behaviors that are commonly used. And this can provide a high quality animation. But the problem is that the provided library are designed to support certain types of apps, for example, mobile apps or website transitions. In addition, such software often requires a high fidelity prototype, so that makes it difficult to explore different ideas in early sketch. Another potential solution in prototyping interactive behaviors could come from the tools that researchers have developed in Western Kai, in context of helping end users easily create illustrated and interactive animation. For example, K-Sketch here. The animation? Yeah. For example, K-Sketch here, it provides an easy-to-use environment where the user can create animation by demonstrating it, and later editing the animation. They can edit the animation on the timeline editor, like a video player or any kind of film editing tool. However, the end result is one single linear animation, which will reproduce the same scenario over and over again. So it may not scale well for a UI that can contain multiple interactive behaviors. Other examples here. The other approach is to provide a graphical packaging environment where a user can specify relationship between elements in Sketch. So, for example, Sketchify and Kitty provides a much easier environment than textual programming, for sure, and allows rich expressivity. But still, this is kind of an end-user programming, and may not be ideal for quicker exploration and iteration at the very early stage of UI design for broader population. So all of these approaches provide a valid solution on its own context. However, we believe that each approach has some issues that makes it difficult to use in the context of creating early prototypes. In general, we want a tool that is agile for rapid prototyping and easy to use for non-experts and expressive enough to support not just certain applications, but general UI application. And we have, if you think of it, if you have a solution for the occurrence of UI design, like pencil and paper, Pencil and paper provides expressive and natural ways to create a rough sketch. But so our question is that what is something equivalent to pencil and paper for prototyping interactive behaviors? So one of the effective methods is to create paper prototypes and then animate the paper cutouts and manually demonstrate the behaviors. And I guess it's pretty satisfying to watch this and people collectively manually demonstrating the game. But however, I mean, imagine how long it's going to take to create that, like create the paper cutouts and then synchronize between people to create certain things. So certainly it would have not been easy. Another problem is that the demonstration is ephemeral, so that you would have to videotape it to archive it, and the paper prototype itself does not know anything about the interactive behavior, and it doesn't know how it should behave. Lastly, there are certain things that cannot be done manually because we're human and we have some limits in motor function. Yeah, those are some of the challenges in these kind of paper prototypes. And as an alternative, we can leverage crowdsourcing. This is Apparition, Walter's previous work, and it addresses some of the problems that we have seen in manual demonstration by recruiting a set of crowd workers and make them collaborate on a real-time shared canvas. So Apparition is a crowd-powered tool where a designer speak and draw a rough sketch of UI that they want to have. And then crowd workers behind the scene will listen to the description and create a refined sketch and so forth. So in the user study, the oops. Was it working? Okay, yeah. So the authors also ask workers to demonstrate simple behaviors like moving gang character to a certain space, like where the requester clicks. And however, it has, it has more benefit than manual demonstration because it's Apparition has it's an electronic shared canvas, but still has some limits coming from the manual demonstration, like behavior being ephemeral, or it's also limited by the motor function, and so forth. So to address these problems, we introduced SketchExpress, a system that can help designers prototype complex interactive behavior in early prototype. And it takes the idea of crowdsourcing from Apparition, and it is in fact built on top of Apparition. So in SketchExpress, a requester or designer verbally describe the interactive behavior that they want to have to the system. And then crowd workers behind the scene, they are listening to the verbal description and they create interactive behaviors in real time. And we provide an easy and expressive method called demonstrate and remix to create a complex behaviors in an early sketch. At the end of the day, the designer will have a sketch that includes a set of interactive behaviors that can be triggered or replayed anytime by anybody. So at the end of the day, you have the sketch, and then there's a lot of different interactive behaviors that you can demonstrate. So from now on, I'll explain how the system allows crowd workers who are not necessarily have any background in design or programming to easily create an interactive behavior using the demonstrate and remix method. So in SketchExpress, one can create an interactive behavior by demonstrating it, like the redraw ID from the case sketch. So I'm going to show you an example. So suppose a requester describes a desired behavior. Let's say the requester wants the crowd worker to create a behavior of Super Mario moving forward or jumping forward, and then the crowd worker listen to the verbal description and start recording, and then name the animation and demonstrate what is supposed to happen. And for that particular behavior, I start recording, and then later you'll be able to replay the animation. So now you're watching creating a jumping behavior where you, if you suppose you're a worker, and then you just drag and drop in a way that you want, and then everything will be recorded in real time, and then so you can replay it in real time as it was demonstrated. So once the behavior is complete, one can reset the animation so that it can quickly restore the initial state of animated elements so that the behavior can be demonstrated again. For some reason, I wanted to have a different kind of jumping behavior where Super Mario do 360 turn. That's tough. And And then you can see that like, all the operations that all the changes that you make are logged in the right side. So that's a basic way to create an animation. And another important method is that the system records and replays the animation by calculating difference between frames. So let's say I created a jumping behavior, and then if I press it again, it's not going to reproduce what is demonstrated, but it will actually make another jump from where it stands. So you could do like you could almost like play games with the created animation. This recording and replaying by delta will expand the expressivity of animation in SketchExpress. And here are some examples. Let's say I recorded an hour hand of clock moving from 1 o'clock to 3 o'clock, which is basically rotation by 60 degrees. And if a behavior is replayed again, the result will be not the reproduction of demonstration, but the hour hand will move from 3 o'clock to 5 o'clock, 5 to 7, and so forth. Another benefit of replaying by delta comes when a user replays multiple animation at the same time as the system. For example, if I want to demonstrate rolling stone, you cannot really manually demonstrate this because you cannot rotate a element while you're moving it. So you can create an animation that rotates the element, and then you can have another animation that translates the object. And then if you play them together, it's going to create this rolling stone animation as we want. Most importantly, SketchExpress allows crowd workers to remix the demonstrated behavior afterwards. So this is an example where the person trying to demonstrate the behavior of mushroom dying when Super Mario throw a fireball like this. And then it's not exactly what I want because I would have to show all the rotation operation, and then there's some delay between operation, and then it's not exactly the duration that I want. So what I can do is I can go to the remix mode, and then it will show all the operation that I have been done while demonstration, and I can change the timing of each operation. So let's say rotation happened in 3 seconds, but I want it to be instant, and I don't want any delay between operations as well. And then I can adjust the timing of each operation so that eventually I will get what I want. So if I have no delay, if I preview it, I'll get the behavior that I want. So having remix function is to address some issue of limited motor function when manually demonstrating interactive behavior for For manual demonstration, an operator has an expressivity in spatial visual dimension as well as temporal dimensions, because they can change something in canvas and they can demonstrate over time. But there are certain things that you cannot do, and by having remixing function, a worker has a control over the temporal dimension of the recorded animation that allows them to be more expressive and create more complex behaviors. Another benefit of remixing function is that because it is adding one more function to, just one additional function to demonstration, it is easy to understand for them to what's possible and what's impossible, so they can understand the range of expressivity afforded by the system. So, yes, we believe that this makes it easy for them to learn the tool. The last thing that we have in SketchExpress is that we treat interactive behavior as a reusable object. So let's say we have a mushroom that has 3 different kinds of behavior, where it could wander around to kill Super Mario, or it could crash when Super Mario jumps on it, or it could knock out when it got hit by the fireball. And let's say Turtle, there's another NPC character, which is Turtle, or Koopa, I guess. And it could share some of the behavior, or it could have its own behavior. So we could make its own behavior separately, and then apply some other behavior. Apply the existing behavior from existing elements. So if I grab the move behavior to other elements, you can actually reproduce the same behavior. So this is an example, I guess, of applying the mushroom behavior to turtle. I just clone one more animation, and then apply to turtle by going into remix mode and change the elements that I want. Okay, so this is an example of how far we can go with SketchExpress. This is a demonstration done by one of our undergraduate researchers demonstrating the game Flappy Bird. As you can see, the game character, the background, and the game itself can be demonstrated separately and performed by one person. And you may be focusing on the left side, but like interesting thing happened on the right side where like by pulling the lever of right animation at right time, you can accomplish the demonstration of a complex game. And like if you could imagine how long it's going to take to like implement this in programming or paper cutouts, you I guess I think SketchExpress has a benefit in that direction. So we did an experiment. So we had 3 different conditions where we compared SketchExpress with original operation, where people have to manually demonstrate the behaviors. And we have another condition where we don't have a remix function. And then last one is the SketchExpress condition where they have everything. And we recruited 18 workers from Mentor. And requester was controlled. Basically, we read a written script to describe the behavior. And then they had a minimal amount of training, video tutorial and self-training that takes about 10 minutes at most. And we then give them 5 different UIs and then ask to create 9 different interactive behaviors. And they are asked to demonstrate each behavior twice because like the benefit will come from the replay. And then we actually annotated the screen recording to measure the quality of the behavior as well as completion time. So we could confirm that we had a statistical significance in like we were able to see the precision increase in over the condition. So we can see in the manual demonstration it's in the C2, which is demo plus replay, and C3, which includes remix function, we could see the gain in the precision. Precision means that they didn't have the unnecessary action, because remix function will allow to skip certain operations that are recorded. Like we got almost 100% precision in C3. We got a 27% gain in recall at C3. We didn't have any statistical significance in C2, but we were able to see a great increase in recall. That's because of the remixing function allows to have more accurate expressive behavior. In terms of completion time, like the increased gain in recall comes at the price of more time to remix the behavior. So in manual demonstration, so recall that we asked them to demonstrate twice. So the blue one is the first try, and the green and yellow one is the second trial. So we can see that there's no difference between blue and the green one in C1 because they're manually demonstrating the behavior twice. But you can see that the benefit of having interactive behavior being replayed comes from once you create an interactive behavior, you can keep replaying it, and like you can see the great benefit in the time that it takes to replay it again. And it doesn't have to be the same set of crowd worker, but anybody can play it. So that interactive behavior itself is not ephemeral anymore. For the sake of time, I'm going to skip this slide, but basically say everyone enjoyed it. And summary, workers can prototype interactive behavior in average 3 minutes with 27% gain in quality. And our contribution is the method of demonstrated remix replay that could be applied to a different domain. And a system that allows crowd workers to quickly create interactive behaviors. And the user study that we did to validate the system. For the future work, we have done like aberration to create to crowdsource UI design, and we did SketchExpress to crowdsource prototyping interactive behavior. And we are interested in how requester could, what are the challenges, what the challenges are for requester to communicate crowd workers, which is in fact under review. And then we are also interested in including machine intelligence to learn from crowd demonstration to automate the process. And I think that's about it. Thank you very much.